Hi, I'm Wilman, and this is my second video for my IB mid-years project documenting the progress of my organizational application, Flow. My previous video mainly covered broad goals of the project and then briefly reviewed some code I had written for the application. Since then, the code has tripled in size and I've added a lot of functionality to the to-do list. The first thing I did before coding was create a checklist of various features I'd like to see for the to-do list to be complete. I didn't get everything done, however, there's been some noticeable changes made visually. I've kept the color palette the same. As a general rule, anything white, for example, the buttons or the list box, are interactable. This is by default from Tkinter, but I thought it was important to point out. I also kept the main bar on the left side that will help switch pages in the future and once I add more functionality. I've also ended up populating it with the first button, which will allow users to create a class. Later in the development, classes will be used to organize everything. So all projects, calendar events, tasks, and other things will be nested under or associated with the class. The next big change that I've gotten rid of the 3 list boxes and now have 1 list box containing all the information about each task. I haven't completely figured out how to format the task because obviously some things don't line up, but otherwise I think it's a big improvement and gives more information to the user about each task. Lastly, I've created 2 more buttons and moved the originally green button, that is now the add button, into a row of 3 above the list box containing the tasks. This is much more faithful to my original design than before. So I'll be going in the order that I added the features because I added features I ended up changing and fixing already existing code. The first problem I tackled was adding classes into Flow. Although right now they don't have much functionality beyond usually helping with the organization, in the future I plan for classes and stuff like tasks to be linked code-wise for more complex interactions. With all this said, the first thing I needed to add was a way for the player to add their own classes into the application. This started with an empty array called classes. Then I created a pop-up window similar to the add menu. However, it needed to be more interactable and have more features than the user, so the user could add, delete, and alter classes because I wasn't giving the class button its own page. This looked like a list box showing off all the classes. Created 2 entry boxes where the user could input what the prompt asked for, 2 buttons, one to create classes and when the entry boxes were filled, and one to delete a class selected in the list box. And finally, an exit button used to close out the window. I ended up needing 3 functions for the classes. The first one initialized the pop-up using the global variable new task. Then created all the nice button layouts and other widgets on the screen like the other pop-up. But this one was different. It's actually inhabited with a list box then created all the nice button layouts and other widgets on the screen like the other pop-up. But what was different with this one was it actually had a list box in it, and on initialization, because the list box for classes is a local variable to the function, it's important to remember that a list box just shows information and can collect user input, and that all actual important data behind the list box is actually saved to an array not seen. The next logical function was the add class function, which was easy enough. It would take information input in the entry box and then made sure it was in the correct format before storing it. The information collected was the title of the class and the difficulty of the class, represented as an integer from 1 to 10. Then it would add new classes to the class list, which is where I hit my first problem. Because the list box showed my data was local to the created window, I couldn't update it from the add class window, which is important to give feedback to the user that their input had gone through. I didn't just want the window to close out like the add button did for the tasks. When I realized that if I closed the window using the delete pop-up function and then recreated the window using the class window function, immediately the window would be recreated and everything in the array would be added to the list box, including the new classes just added. The last function directly related to the class was the delete class function. All it did was send the index position of the currently selected object in the list box, and then it would delete the same index from the class array and then open and close the window to update the list box. Just as a reminder, the index position is something that is in an array or string. So think of the alphabet B. B comes second, but because we start counting from 0, we would say B has an index of 1. This comes in handy if, for example, we have an array with the whole alphabet in order, and each has its own element. Then if I wanted to delete or add another element to the array, all I would have to do is give an index position and then what I wanted to change. This would be important for later with the sorting code. It also it's important to note that 2 new functions were created while I was coding the class function. I realized you could create multiple pop-up windows which would break the code, so I added the on and off function. Simply what they do is go through all the buttons on the page stored in an array and change their states to disabled, so you couldn't interact with them till the on function was called, and which went through the same arrays and changed the states to normal. Whenever I create a pop-up window, I call the off function, and whenever a pop-up window is closed, which they're all closed using the same function, the delete pop-up function, the on function is called. Chronologically, the next thing I did was delete the two of the list boxes and elongate the third. Then I changed how tasks were added. From now on, whenever a task was created, it would create a dictionary. Then store the dictionary in the task array. A dictionary is similar to an array, but each element has 2 parts, a key and a value. So all the keys are the same and all the values are unique for each task. This allowed me to, regardless of task, simply call for an element of the task, like the title of the task, and place it at the very beginning of the line by calling the uniform key, which gives the unique key. And then this is done for each task whenever the list box is updated. The major simplification allowed me to store more information about each task. For example, the importance and difficulty attributes of each class, and then present it in a cleaner fashion. This will also make coding the sorting aspect of the function much easier down the line. Now that I have an easier way to show more information, I of course decided I would show everything about each task. Now that I had an easier way to show more information, I of course decided I would show everything about each class. This involved showing each task. This involves showing the class. However, the user could previously input anything they wanted for the class, but later it's going to be important for consistency that each class be uniform when a task is attached to it. This meant I had to restrict the choices of what the user could input. I did this by replacing the entry box in the add menu with a radio button. A radio button is a UI element that allows the user to pick from mutually exclusive options, such as the classes. Essentially, if you have a task from history class, it can also be associated with math class. So in the pop-up menu, for the add task, I had a for loop that would index through the classes in the classes array and create an option as a radio button that the user could select. And then when the add task function was called, the argument would be the value of the radio button. I hadn't originally planned to, but I also ended up turning the type option into a radio button, which is important for the next part. This was a little easier having had practice with the previous radio button for classes, which involved me trying to evenly space out the options with for loops. Whereas for the type radio button, I manually placed each option. For the future, I would like to add a way for the user to customize the types in the settings, but this is very low on the list of must-dos, so it's going to have to wait. Now that I've standardized the classes and types, I can mess around with the importance and difficulty attributes of the tasks. So this was a system that I had used before, and I really enjoyed it, and it was an offshoot of the Eisenhower matrix, but I changed some stuff around. Firstly, I changed urgency to importance, which was an interesting semantic change, but arbitrary. I just liked the sound of it more. And then I added difficulty, which means I'm presuming that everything is important in the original sense of the word and needs to be done. Next, I needed a way to give these attributes meaning or value in the form of an integer, so I ended up using the formula the type plus the class is equal to difficulty, and type plus date is equal to importance. This gets a little weird giving integer values to these words. Class was the easiest. Whatever difficulty level the user inputted for the class was what was used. Then for the date, I said if it was past a certain time, it was important to do. For example, if it was 2 weeks before this was due, then the date value would be 1, but if it was due today, the date's importance would be 5. Where it gets tricky is for types, which for homework study were homework, study, test, quiz, project, and these each had 2 values depending on if they were used in the difficulty or importance equation. For example, take test type and the homework type. If you have homework coming up, I decided it would be less important than if you had a test coming up, and the test gets an importance score of 5, whereas homework gets an importance score of 2. Then, for example, take their difficulty scores. A test I gave it 3, and homework I gave it 1. This is important to note that this is a task list, so when I say test or quiz, I really mean study for a test or quiz, even though I have a separate study type. That is mainly for reviewing information in the class, generally more of a build-up to the large end of year assessment instead of test or quiz. After calculating these values in the add function, I store them in the task dictionary for later usage. A very minor change I made was I created a button for deleting task and moving the add button. This would what would happen is whenever an element in the list is selected and the complete button is clicked and it would send the index position of the selected element of the list box. Changes that tuple into an integer, gets the element in the index, gets whatever string is stored there. Then I use the split method to create an array with the title in index 0 and the rest of the string is index 1 of the array. Create a new variable that's just the title so that I can compare it to titles in the tasks list. And once they match, I remove the task from the task array and then I update the list box by clearing it and then going through the task array again. This is a great example of what I meant in the last video if I would control the list box by changing the task array and then showing those changes in the list box, because the list box does have a delete method, but this is better because it gives me more control over all the tasks. It's also important for me to note that I can't just directly take the index in the list and then use it to delete the value in the task array, and the reason why will become more apparent very soon. The last thing I did that ended up taking a plurality of my time is creating the sorting methods for the tasks. This is going to be probably the most technical part of the video where I'll be focusing on my actual code and not just broad executions of my code. I've already explained how I create a pop-up window, so I won't talk about it too much. Just know that when you press the sort button, a pop-up window appears on the side of the list box, and of course it has the typical widgets used for interactions. The main ones of importance are the list box, the buttons, and the buttons. The list box contains all the ways the task can be organized by date, difficulty increasing, difficulty decreasing, importance increasing, and importance decreasing, and the suggested order. The first 5 methods mentioned actually all function the exact same with variable names changed. So I'll cover those all at once, and then I'll point out the one difference using the date as an example. Then I'll cover the suggested order separately. So for the date, the first thing I had to do was get something I could compare. Currently, the only thing we have to go off of is the user inputted date, which should look like month, day, year. But that is the form of string, and those go alphabetically, not numerically. My solution to this was to convert each part of the date into an integer value. I would then multiply it out, so month would be multiplied by 30, and then year would be multiplied by 365. Not an exact measurement, but close enough to know that everything is in days. I added it all together. That is what I'm going, and I decided that's what I'm going to sort. So I add this functionality in the task function, add task function, and sort it under do number or do hashtag, which is the actual variable I'll be sorting through. So if the user selects to sort by date, the task will arrange themselves in chronological order from the earliest due date to the furthest one away. Some important terminology before we get into the really technical part of the explanation is what a for loop is. A for loop is a loop that iterates through a specified number of times, and it can iterate through arrays, dictionaries, or just a plain range. The first part to get that end goal of chronological order is actually setting up some variables. First, I create tracker, which is a dictionary, and its job is to get the do hashtag as a key, and its value being index position in the original task list. Then compare it to where we'll actually be sorting the do hashtag value out. In theory, the earlier the date, the lower its value will be. However, these variables remain empty until populated during the for loop, which iterates through the task array and then takes the necessary values and adds/assigns them to the previously mentioned variables in the previously mentioned ways. Next is where the do hashtag variables actually sorted by calling the sort method in the comparison array, which arranges those numbers in ascending order, which is the only difference between increasing and decreasing sorting methods. If it was increasing, all I would do was reverse the method. Also, moving on, I know that my final goal is going to be create a new array that I will append the task to from the original task array in the correct order. This means I need to find the correct order using the index position. This means I need to find the correct order when using the index position, call those tasks in the new, and then call those tasks in the new order, which sounds confusing, and it is confusing without more examples, both visual and vocal. So up to this point, I've had a tracker that has the do hashtag in their original index positions in the task array, but not in the proper order. I also have an array with the do hashtag values in order, but with no relation to the original task array. So if I can somehow communicate the correct order to the tracker dictionary, I can then put the index position of the do hashtag variable into the correct order if they're not already so, which is what the second loop, for loop does. It iterates through the comparison array, and then using what it iterates through calls values in the tracker dictionary using the keys and that are now in the correct order and appends those values to a new array called list. Then I create another array called copy, which would be a copy of the original array in the sorted order. It means it needs full information of each task, not just the due hashtag variable. Then I got how many tasks are in the original task array using the length method, and then create a for function that iterates through that many times. We're using the index position stored in the last array, which is the correct order for the task, plugging that into the task array. I would then call for those tasks in the task array and then append them in that order to the copy array. Now that you are thoroughly confused, I'll explain the whole thing without the technical jargon before confusing you again. Imagine I have an original array, and each element of this array is a dictionary with several keys and values. But I only really care about the letter key, which has a value of one letter, A, through Z. Within the original array, these letters are in random order. For simplicity's sake, let's say there's only 3 dictionaries in the array, and look at each letter variable. They're in the order B, C, A, but I want them in the alphabetic order, so I create a new dictionary with the letter values and their index positions in the original array. This would look like what you're seeing on screen now. Then I create another array called comparison, and I just took it in whatever order the letters are in originally, so that would look like this. I would then call the sort method on the comparison array, and then we'll put the letters in alphabetical order. But now I need to get the indexes in order too. So I create another array called last, and then I use a for loop to iterate through the comparison list and plug the values from the comparison list into the dictionary, which gives back the values and append those in order to the last array. Essentially, the dictionary is acting like a translator which spits out 201, which is the order that the original array elements should be put in comparison to where their actual index position is in the original array. So next I create a new array that will put these dictionaries in the correct order by looping through the last array, each time taking the value used in the index through the original array and pulling out that task and append it into the new array. Now, as far as the letter variable is concerned, the new array is in the correct order. I hope that made more sense the second time, and now to move on and talk about how I sorted through the suggested order method. Then the suggested order is different because it involves 2 variables, importance and difficulty. Before getting into the coding part, I'll explain why I thought the best order was and some failed ways I thought to sort it. I decided the best way to tackle a to-do list is to go by what's most important and then least difficult. So if you have a task with an importance of 10, it needs to go first, and you have a 5 tasks, each with a level 10 importance, which one should be done first? Obviously, you should start with the easiest one and go to the next hardest one. So if you do run out of time, you gain the most done possible. During my first attempt, I thought I could use a direct and inverse function to calculate this. It didn't work for reasons I don't understand, so moving to the next best solution, which I hope is simpler after understanding how I sorted the dates or letters. On screen, I'm hoping to give a visual presentation that isn't my actual code, but shows you what my code does and tries to really explain and break it down. Because just reciting how my code works is a little confusing, even for me. So instead of using the function, I decided I would create 10 empty arrays, each the spelled out number, so 1, 2, 3, and so on. All of these arrays are sorted into another array, the master list, so that I can iterate through all of them without having to individually call them. The first thing I have to do is iterate through the task and assign each task to a list based on the importance. So if the importance is 1, then it'll end up in the 1 list. However, it is stored as a dictionary with difficulty as the key and its index in the task list as the value. Now that importance is sorted out, I move on to the more complex task of sorting out the difficulty. I create a new array called the new master list. I then iterate through the master list array, creating a variable called compensator. Then iterate through each of the individual arrays, appending each difficulty value to the compensator array. Sort and reverse that array, and after that, a for loop iterates through the compensator array and assigns each value in the array its index position in the number array, not the task list. This information is stored in a variable called copy. Then the copy dictionary is appended to the new master list, taking a moment to regroup and explain what's just happened. Essentially, we already know what the order. Okay, taking a moment to regroup and explain what just happened. Essentially, we already know the order to do the list in, which is ascending order. Now we know the correct order in which each of these lists, within each of those, but we need to get the original index values. Moving forward, the next step is to access those original values by iterating through the new master list, then getting the values of the dictionary stored in the new master list, then iterating through those values. A reminder of these values are the index position in the task list. Those values are appended to the final thing array, and then I reverse that array because it cancels out the previous reverse that I had put in mistakenly but didn't want to take out at the time for fear of destroying hours of work. Then I create the final thing for real variable. This variable, besides having been very longly named, will hold the final product which all tasks are ordered. On the screen, what I'm showing is test code that I did with random numbers. All the print statements kind of show where I got stuck and had to pause and to see where I was in relation to my final goal and what the next step was. I found that with these more complex logical problems, it helps to break it down and not think so linearly, especially being newer to this language and these types of problems. For example, I've never tried to organize any array like this when coding games. And when I spent hours working through these problems, it was really good for me to have paper nearby. Honestly, I probably didn't utilize or draw out the step by step as well as I could, but randomly writing stuff down haphazardly seemed to help stuff click. For example, I was working on sorting by date. I somehow in my confusion managed to figure out copy.append task index, which doesn't even show up in my code, but it helped me figure out where I should be aiming because originally I'd been aiming for changing the task array itself, which was just not going to work. So instead focusing on organizing the task list by representing each element by its index, then knowing I would need to create a new array to copy that I have to append those elements in the given order was a big breakthrough. The only other major problem I had was at one point I spent over an hour trying to figure out a bug in my code where the original sort methods weren't working, which was odd because when I tested them they seemed to work. But then when the update function was called, the wrong list was being iterated through, so I had to fix that, which involved me creating a whole new function to test, and it still didn't work. And then I created a tag system so I knew where the calling update, who was calling the update and how many times. Turns out it had been some sloppy code on an if ladder that allowed for the update function to be unnecessarily called. So I fixed that, and writing this script really made me realize I need to go clean up my code. Even though I can decipher my code, that doesn't mean others can. And from what I understand, in any professional work environment, it's important for code to be uniform and easy to understand for others to build on and maintain. My code isn't that, and I want to get into the habit. So my goal for this week will be to document all changes I make in my code. I know there's more I wanted to do with the to-do list, but I don't think I have time anymore, so I'm going to have to move on to the planner functionality. I also want to figure out how to save changes and export the project into a somewhat usable state before having to turn it all in. Thank you for watching my video.